Building a secure end-to-end cloud pipeline from scratch can take weeks of configuring files and resolving dependency errors. Today, we are skipping the boilerplate by starting with a pre-built blueprint repository. By the end of this session, you will have a fully automated pipeline deploying a live 3-tier application to a secure cloud cluster. This checklist shows the 4 things you need to follow along: an AWS account, a GitHub account, a container registry, and local command line tools, including AWS CLI, Terraform, and kubectl. First, fork the provided repository to your GitHub account and clone it to your local machine. Once cloned, switch over to the DevOps branch. This branch contains all the infrastructure code we need to get started. Starting with a complete blueprint shifts your focus. Instead of writing repetitive configuration scripts line by line, you can concentrate on mastering the macro architecture of the system. Navigate into the Terraform directory on your machine. Run the initialization command to download your provider plugins, followed by the apply command to provision an AWS virtual private cloud and an elastic Kubernetes service. Looking at this AWS console dashboard, we can see the new EKS cluster named Journey is provisioned and showing an active status. To connect your local machine to this remote cluster, run the AWS EKS update kubeconfig command, passing in your specific cluster name and region. Verify the connection by typing kubectl get nodes. You will see the active worker nodes responding, proving your local terminal can now direct the remote cloud environment. Using infrastructure as code guarantees exact reproducibility. You define the state in text, and Terraform builds it perfectly every time, eliminating the human errors that come with manual console configuration. With the infrastructure running, let's examine the specific code configurations that upgrade this standard deployment into a secure DevSecOps pipeline. Our multi-stage Docker build creates a non-root user, drastically reducing the attack surface. At the network level, our Kubernetes policy isolates the database, blocking external traffic. Inside GitHub Actions, automated gates scan container images for vulnerabilities and inspect infrastructure manifests for misconfigurations. By embedding Subsurity into the code, compliance shifts from a manual post-project review into an automated barrier that activates on every single commit. Let's put those barriers to the test. Open the repository's README file, add an empty space, and push to your DevOps branch. Over in your GitHub Actions tab, this commit instantly triggers our integration pipeline. You can watch the 12 distinct stages process in sequence. Notice the execution halts here. The Trivy image scan and Checkov stages have both failed, turning stark red on the tracker. This failure is a systemic success. The pipeline caught an outdated note package in our backend and a misconfigured resource tag in our Terraform code that were intentionally left in the blueprint. Once you fix those vulnerabilities and the pipeline passes all security checks, the final automated step executes a script to update the Kubernetes manifests with the newly approved secure image tag. These automated gates act as a ruthless filter. They ensure that bad dependencies or misconfigurations are caught and contained right here in the repository before they ever reach your live cloud environment. Now we need to sync those approved manifests to the cluster. Retrieve the ArgoCD admin password from your cluster secrets and establish a port-forward connection to access its local dashboard. In this deployment panel, create an application. Paste your repository URL, set path to K8s, choose the DevOps branch, and toggle Automatic Sync. Execute the creation command. This action links your remote repository directly to the live Kubernetes cluster. ArgoCD immediately detects the new manifests and starts spinning up the required pods, persistent volumes, and services, resolving all the application dependencies in real time. The GitOps approach removes manual deployment entirely. By forcing the live server environment to strictly mirror the version-controlled repository, whatever is securely merged in Git becomes the absolute source of truth in production. For final verification, run a kubectl port forward command on the front-end service to map the application's traffic to your local machine. Open your browser to the local port, and you will see the fully functional 3-tier blogging interface running smoothly on your secure infrastructure. We took raw code, passed it through automated security gates, packaged it into isolated containers, and handed it off to ArgoCD for a GitOps managed deployment onto an auto-scaling cluster. Before you close your terminal, run the infrastructure destroy command and confirm the deletion. Do this immediately to prevent your cloud account from accruing ongoing hosting charges for the cluster and volumes. Mastering DevSecOps requires controlling the entire lifecycle. You must ensure your environments are securely built, rigidly tested, and cleanly dismantled to protect both your data and your resources.